Every morning, in kitchens across the world, condensed milk disappears into coffee cups, desserts, bakery mixes, and breakfast tables without a second thought for most people. It is just another cheap product sitting quietly on a supermarket shelf, a small metal can, sweet, thick, ordinary. And yet, that ordinary can hide one of the most massive industrial systems in modern food production. Because milk is not supposed to survive. Fresh milk begins deteriorating almost immediately after leaving the cow. Bacteria multiply fast, temperature changes destroy stability. Even a small failure in handling can ruin thousands of liters in hours. But condensed milk can survive for months, sometimes years. And that raises a strange question. What exactly had to happen to stop milk from dying? Across the planet, more than 400 million cans of condensed milk are consumed every single year. Behind every spoonful is an invisible chain of farms, machines, laboratories, tanker trucks, pressure systems, sterilization chambers, and factories that never truly sleep. Most consumers never see this world. They only see the final product. What they do not see is the scale. Before condensed milk reaches a grocery shelf, the process begins far away from cities, inside enormous dairy operations where production moves with almost military precision. Thousands of cows, miles of stainless steel piping, rotating industrial platforms, temperature-controlled storage systems, and an endless race against time. Because the moment milk leaves a living body, the countdown begins. Modern food manufacturing is built around a simple reality. Nature wants milk to spoil. Industry refuses to let it happen. That conflict between natural decay and industrial preservation created an entire hidden civilization operating behind the walls of food factories. And few products reveal that hidden system more clearly than condensed milk. The story begins long before the factory, long before the sugar, long before the can itself. It begins inside one of the most industrialized biological systems on Earth, a modern dairy farm.
From a distance, modern dairy farms still look familiar. Open land, rows of cattle, morning fog drifting across the fields. At first glance, it still feels like agriculture. But the closer you move toward the center of the system, the more that illusion begins to disappear. Because modern dairy farming is no longer built around tradition. It is built around synchronization. Every movement is measured. Every cycle is timed. Every animal becomes part of a continuous industrial flow designed to keep milk moving every hour of every day. And nowhere is that transformation more visible than inside the milking parlor at some of the largest dairy operations in America. Enormous rotating platforms slowly turn beneath bright industrial lighting while dozens of cows step into position with mechanical repetition. From above, the system barely resembles a farm anymore. It looks like a biological assembly line. Up to 80 cows can be loaded onto these rotating systems at once. As the platform moves, workers and automated equipment perform the same sequence again and again and again. Attach, extract, release, rotate. The rhythm never truly stops. For centuries, milking was physical labor performed by hand. A farmer could only process a few animals each hour. Now the system processes nearly 100, not because cows changed, but because humans rebuilt the environment around them to maximize efficiency at industrial scale. Vacuum-powered milking machines seal tightly around the animal and begin extracting milk using carefully controlled pressure designed to imitate human touch. Warm milk immediately rushes through stainless steel pipelines toward refrigerated storage tanks before bacteria has time to spread. Everything is optimized to reduce delay. Because delay is dangerous. And that pressure changes the entire meaning of farming itself. Traditional farming adapted itself around nature. Modern industrial farming increasingly asks nature to adapt itself around the system. Milk production is monitored. Feeding schedules are calculated. Environmental stress is reduced because calmer animals produce more stable output. Even the reproductive cycle becomes part of a carefully managed production rhythm. Most dairy cows are milked twice every day for roughly 305 consecutive days before entering a short recovery period prior to giving birth again. Then the cycle repeats, again and again. From the outside, people still imagine farming as something slow and natural, but inside facilities like these, biology has been integrated into industrial logistics with astonishing precision. The cow is still a living animal, but it has also become part of a manufacturing system. Not in a science fiction sense, not in a dystopian sense, just in the practical reality of feeding millions of people every single day. And the scale required to sustain that demand is almost difficult to comprehend. Some dairy farms now manage thousands of animals at once. Networks of tanker trucks move continuously between farms and factories. Refrigeration systems operate around the clock to slow bacterial growth before the milk can spoil. Because despite all this machinery, milk remains incredibly fragile. The moment it leaves the animal's body, the countdown begins. Temperature changes by only a few degrees, and bacteria can begin multiplying rapidly. A contaminated storage tank can destroy massive quantities of product before anyone notices the problem. A transportation delay can destabilize an entire shipment. That is why the milk is immediately cooled to near freezing temperatures, usually between 2 and 3 degrees Celsius, before entering insulated storage systems. The cold buys time, but only a little, because underneath all the automation, all the machinery, all the industrial efficiency, the system is still fighting biology itself. And biology always pushes toward decay. By the time tanker trucks arrive at the processing facility, some of that milk has been out of the cow for less than 6 hours, but even then, the factory still does not trust it. Not yet, because before condensed milk can ever become stable enough to survive for months, the industry must first confront an invisible threat moving through every drop: bacteria.
By the time raw milk arrives at the processing plant, the factory has already made one assumption: the milk is dangerous. Not because something went wrong, but because raw milk is naturally unstable. Inside every tanker truck entering the facility, there is a biological product moving against time. Even under refrigeration, microorganisms can still survive. Tiny shifts in temperature can accelerate bacterial growth. Invisible contamination can spread through thousands of liters long before human senses detect anything unusual. And at the scale of industrial food production, small mistakes do not stay small for very long. That is why every incoming shipment is tested before it is accepted, inside laboratory rooms hidden behind the main production floor. Technicians examine samples from every tanker load arriving from nearby farms. Fat content, salt balance, temperature stability, antibiotic contamination, bacterial risk, everything is measured, because once milk enters the larger system, a single failed batch could compromise enormous quantities of product moving through the facility at industrial speed. The modern food industry does not trust appearances, it trusts data. Only after passing inspection does the milk move deeper into the factory, toward a place workers sometimes refer to simply as the city of tanks. Towering stainless steel storage systems hold millions of liters at near-freezing temperatures, while the production cycle continues day and night without interruption. The scale feels almost disconnected from the product itself. People think about condensed milk in spoonfuls. The factory thinks in millions of liters. And yet, even here, the milk is still unstable, still vulnerable, still temporary. Because refrigeration slows bacteria, it does not eliminate it. To truly preserve milk, the factory must begin changing its structure. The first transformation happens inside a centrifugal separator spinning at nearly 7,000 revolutions per minute. At those speeds, gravity itself is no longer strong enough to control separation efficiently. So the machine creates something stronger: artificial force. As the milk spins through stacks of conical discs, heavier skim milk is pushed outward while lighter cream moves toward the center. Thousands of liters are processed every hour in a system designed to control fat levels with astonishing precision. To the viewer, it looks mechanical. But underneath, the factory is manipulating physics itself to stabilize biology. And the deeper the process goes, the less this resembles traditional food preparation. The next threat is bacteria, not visible contamination, not dirt, not spoilage. You can smell but microscopic organisms capable of surviving inside the product itself. That threat leads to one of the most important moments in the entire process: pasteurization. The milk first drops to near freezing temperatures, before entering a heat exchange system that rapidly raises it to approximately 72 degrees Celsius. Then comes the critical phase, the retention tube, for roughly 15.5 seconds. The milk remains inside a carefully controlled thermal environment designed to destroy dangerous microorganisms without damaging the product itself. 15.5 seconds, too short, and bacteria survive. Too long, and the milk begins changing in unwanted ways. Modern food preservation often depends on timing so precise. Consumers never realize it exists. The process takes less than a minute, but that brief thermal exposure fundamentally changes the milk's chances of survival. For most of human history, raw milk spoiled quickly and unpredictably. Before industrial pasteurization, contaminated milk contributed to widespread disease outbreaks and dangerous foodborne illness. Modern consumers rarely think about that reality anymore because the system hides it successfully. But pasteurization alone is not enough to create condensed milk. The factory still faces another problem: water. Milk contains enormous amounts of it, and water gives bacteria room to survive. That is where sugar enters the process. Most people think sugar is added for flavor. Sweetness is only part of the story. In reality, sugar also acts as preservation technology. Large quantities are blended into the milk, not simply to improve taste, but to help stabilize the product itself by limiting microbial activity and extending shelf life. The sweet flavor people recognize so instantly is partially the taste of industrial preservation. Then the mixture is heated again to fully dissolve the sugar and prevent crystallization later inside the can. Every stage removes another weakness. Every stage buys more time, and beneath the noise of pumps, steam, and flowing pipelines, the factory continues fighting the same enemy it has been fighting from the very beginning: decay. But even after refrigeration, after separation, after pasteurization, after sugar stabilization, the milk still contains too much water to survive long-term storage. Now the system must do something far more aggressive. It must physically remove part of the liquid itself, and that requires some of the largest and hottest machinery in the entire factory.
At this point, the milk has already survived refrigeration, transportation, bacterial testing, separation, pasteurization, and chemical stabilization. But the factory still does not consider it safe enough, because cold temperatures only slow decomposition, sugar only restricts it, pasteurization only reduces the threat. None of these processes truly solve the fundamental problem. Milk still contains too much water, and water gives biology room to return. So now, the factory moves into its most aggressive phase yet: transformation. Deep inside the facility, Towering stainless steel structures rise several stories above the production floor. Steam drifts through the air. Pumps vibrate beneath metal walkways. Pressure valves hiss continuously in the background. This is no longer food preparation. This is industrial-scale control over biological instability. The milk enters massive evaporator systems designed for one purpose: remove water before bacteria can reclaim the product. Inside the evaporators, the liquid flows through long vertical tubes surrounded by chambers of superheated steam. As temperature and pressure rise, water begins separating from the milk itself, not violently, not instantly, but continuously, precisely, relentlessly. The process removes roughly 60% of the water content while concentrating sugars, proteins, and fats into the thick substance consumers eventually recognize as condensed milk. And the deeper the process goes, the more unnatural the transformation becomes. Fresh milk was once thin, fragile, temporary. Now the factory is reshaping it into something dense enough to survive industrial storage and global transportation. At this scale, preservation is no longer passive. It is engineered. Every pipe inside the factory exists to control timing. Every valve exists to control pressure. Every temperature reading exists to delay decay for just a little longer, and the system cannot stop, not for an hour, not for a day. Because modern food manufacturing survives through uninterrupted motion, tankers continue arriving. Storage systems continue circulating. Steam systems continue operating. Conveyor belts continue moving. The factory behaves less like a workplace and more like a living industrial organism consuming energy around the clock. And yet, even after evaporation, the process is still unfinished because instability can still return. The concentrated milk now passes into another system designed to solve a different weakness: texture. Without further treatment, fats inside the product can separate over time, creating uneven consistency during storage. So the factory subjects the milk to homogenization. Under intense pressure, fat particles are broken into microscopic uniform sizes small enough to remain evenly distributed throughout the liquid. Consumers experience the result as smoothness. But behind that smooth texture is another layer of controlled mechanical force shaping the behavior of matter itself. By now, almost nothing about the original milk remains untouched. Its temperature has changed. Its chemistry has changed. Its structure has changed. Its biological stability has changed. Modern condensed milk is no longer simply preserved milk. It is reconstructed milk. Then comes one of the final and most unforgiving stages in the entire system: packaging. Inside high-speed filling lines, sterilized containers move through synchronized mechanical systems designed to minimize exposure to contamination. Automated machines dispense exact quantities into every can, while sealing systems lock the product away from outside air almost instantly. Precision here is absolute. A sealing failure measured in millimeters could compromise entire production batches, because after all this effort, biology is still waiting for a chance to return. That is why the sealed cans enter one final stage of industrial survival: autoclave sterilization. Massive pressurized chambers flood the containers with high-temperature steam, capable of destroying remaining microorganisms still hidden inside the product. The conditions are intense: heat, pressure, time, all carefully controlled. This is the final barrier between long-term stability and spoilage, and when the process is complete, the result sitting inside the can no longer resembles the fragile liquid that left the cow only hours earlier. What began as a highly unstable biological substance has now been transformed into a shelf-stable, industrial product capable of surviving transportation across continents, storage in warehouses, and months on supermarket shelves. Most people see condensed milk as a simple convenience, but inside factories like these, convenience is built through heat, pressure, timing, chemistry, automation, and constant mechanical control operating every second without failure. The can itself was never the true achievement. The real achievement was building a system capable of holding decomposition back at industrial scale.
By the time condensed milk finally leaves the factory, most of the real story is already over. The consumer will never see the tanker trucks arriving before sunrise. They will never hear the pressure valves releasing steam inside the evaporator towers. They will never watch laboratory technicians testing raw milk for contamination before production can even begin. What reaches the supermarket shelf feels calm, simple, effortless. But modern convenience often hides extraordinary complexity behind ordinary objects. And condensed milk is only one small example inside a much larger system, because factories like these do not simply produce food, they preserve stability every hour. Millions of people depend on industrial systems they never think about. Refrigeration networks, transportation logistics, sterilization procedures, automated packaging lines, continuous energy supply, precision engineering. Entire civilizations now rely on these systems functioning correctly every single day without interruption. And most of the time they do, which is exactly why they become invisible. Modern food systems are designed to erase awareness of fragility. Consumers see abundance, factories see risk, a delayed shipment, a failed cooling system, a contaminated storage line, a pressure imbalance inside sterilization equipment at industrial scale. Small disruptions can move outward very quickly. That is why these facilities operate with such relentless precision. Not because precision is impressive, but because precision is necessary. Without it, modern food stability begins to collapse. And perhaps that is the strangest realization hidden inside something as ordinary as condensed milk. The product itself is not the miracle. The miracle is coordination. Thousands of workers, engineers, drivers, machine operators, dairy farmers, laboratory technicians, maintenance crews, energy systems, transportation systems, all synchronized together to perform a single task humanity once struggled to solve for thousands of years, keeping food alive long after nature intended it to disappear. For most of human history, preservation defined survival. Entire societies depended on salt, drying, fermentation, smoke, and seasonal storage just to make food last through winter or survive long journeys. Today, industrial systems accomplish that preservation so effectively that many people barely notice it happening anymore. But underneath the supermarket lighting, the old battle never ended. Biology still pushes toward decay. Bacteria still wait for opportunity. Time still destroys unstable food. The difference is that modern civilization now fights that battle using steel, steam, pressure, refrigeration, automation, chemistry, and non-stop industrial coordination operating across enormous distances. And all of it exists so an ordinary can of condensed milk can sit quietly on a shelf for months, waiting for someone who will probably never think twice about how it got there. That may be the final paradox of industrial food production. The more successful the system becomes, the more invisible it feels. Consumers experience convenience. Factories experience constant resistance against instability. And somewhere between those two realities, modern civilization continues feeding itself through systems so massive and so precise that most people only notice them when something goes wrong. The next time condensed milk pours slowly from a can into a cup of coffee or across a dessert, it may still look simple, but hidden inside that thick white stream is an entire industrial civilization working continuously to hold decay back for just a little longer.